Video 7. We're going to finish out here our chapter with this video. We will continue to discuss equations of circles, but we're going to do a little bit more with our equations of circles. We're going to now actually involve our completing the square process that we've been practicing this chapter. And so the first thing I want to talk about is we have been writing the equations of our circles in what's called standard form, where we can kind of see our center kind of embedded in here into our x and our y, and we can see what the radius squared is. Now, this is often called the standard form or the center radius form because it uses the center and radius numbers in its form there. But what would happen if we decided to FOIL or double distribute these squared terms? And so if we were to square those out, if we were to FOIL or double distribute them, if I took this particular equation and did all that and added all my like terms, and really the only like terms that we end up seeing are the constants here, and if I were to subtract over this 9 over with this 4 and this 25, I would end up with just a constant of 20, positive 20. So the general form of a circle is when we have x squared plus y squared plus some c term, c coefficient of x, plus a d coefficient in y, plus our constant. Now the c, the d, and the e term, they could be positive or negative. So seeing this plus sign in front of each of those three coefficients isn't indicative that those must be positive signs. They might in fact be minus signs or negative signs. So what we're going to practice on today in this video with one example, and then I'll give you one to work on, is what if I started you out with the general form and I want you to work backwards, if you will, up to the standard form, the center radius form. That's what we're going to discuss, and it's going to involve completing the square. And it's really not that bad of a process compared to what you have been doing with completing the square. So I've got an example. It's already kind of worked out here. And then we'll do an example, or I won't do an example together, but I'll just walk you through this one. So if we started out with this general form here, this center radius, or we want to convert to center radius or standard form, what we want to do is we want to pull together our x terms and our y terms together, and then the constant we kind of want to shove over to the other side of the equation. So notice there's an x squared term here, and let me get a different color here so we can see it a little better. There's an x squared term, and there's a minus 4x term. So notice that I took both of those things and I just put them kind of back to back. So they're kind of clustered together with each other. And then I took all the y terms. So there's a y squared term and there's a minus 6y. And then I clustered those terms together. So I have my x terms, I have my y terms. And what you might consider doing is leaving a little space after the last x term and a little space after the y term. And then the constant, this plus 8, I just threw on the other side, and now it's a negative 8 over here. So at this point, what we want to do is complete the square, but we want to complete the square with the x's and complete the square with the y's. So our coefficients in front of our squareds are both 1, so we can go ahead and start the next step here. We want to take our b term of our x, which is negative 4, and we want to take half of that b term and square it. So half of negative 4 is negative 2, and negative 2 squared is 4. So there's where this 4 comes into play. This is that half b term squared. And whatever I add to the left side of the equation, this plus 4, I have to add to the right side of the equation to maintain algebraic equality. Now at that point, I'm going to go complete my y's now. So again, half of my b term in the y's, so half of negative 6 is negative 3, square negative 3, and I'm going to get a plus 9. So I put that there on the left, and I put it over here on the right. Now, my negative 8 plus 4 plus 9 ends up being 5. And now we want to finish kind of factoring, if you will, and we didn't really need to think of this as factoring, but we've got two trinomials here. We have an x trinomial and we have a y trinomial. And we want to factor those into their perfect squared formats. So half of the b term in the x was the negative 2. So it's x minus 2 quantity squared. Half of the negative 6 here in the y was negative 3. So it's y minus 3 quantity squared. And now we've got our standard form for our circle. Now that we can see this circle, before, when we first started this problem, we really had no idea what the center of the radius is. But once we convert it from general form to standard form, now we know that this circle is centered at 2, 3, and it's got a radius of the square root of 5, whatever that is. So you can see that having equations of circles in standard form or in center radius form is a really helpful thing because we can see the center and the radius immediately. When it's in the general form, we don't see what the center and radius is immediately. So I want you guys to practice this one here. Convert this one to standard form. This is already in general form. But again, group together your x stuff, group together your y stuff, throw the constant on the other side of the equation. And complete the square twice, once with the x and one with the y, and we'll discuss this one tomorrow in class. And that's all.